recorder. Thank you, Ed. I've already got that one. And this is the best warning I can give you for this pleasant Thursday morning. Right. We're just going to finish off the section on service programs. And close that particular chapter. I'm not seeing any emails with questions. I'm a bit concerned. Either I'm doing too good a job or not a good enough job. But we'll wait. If you can think of any, just put them up on the chat box. Right. The thing we want to look at now is an element of service programs. When we were talking about service programs on Tuesday, we got to this diagram, and I explained that we have in the service program itself, we have an export symbol table, which we control using the binder source to make sure that the export symbol table is under control at all times and that it's very precise. Because by doing this, as I explained, we can get comfortable with the service programs and use them effectively. On the other hand, in the program itself that is going to be using service procedures, we have an import symbol table, and during the compilation of this program using the create bound RPG or the create program, these import symbols, the procedures that are required to be imported from somewhere else, have to be resolved. And if you compile and it doesn't find any procedures, your compile listing will be fine, but your job log will indicate that there are unresolved procedure pointers. Now, that is very irritating, and I have evolved a method of making sure that you can minimize that situation as much as possible and have a nice clean set of programs that compile cleanly over a number of service programs. So I'm going to switch to, I think I had the green screen somewhere. Yes, here we are. I had, no, but I didn't have that. I've got to switch this one on. I'm going to switch to the green screen. First, this here that you're looking at is the binder source for a service program that makes up part of the AO product. As you can see, there are a series of modules, quite a few of them. Some of these modules have one procedure in, some of them have 15 procedures in them. And you can see there's the binder source, which controls this procedure. And there is the export symbol table for this particular service program. However, and this is the important thing to understand, this service program uses procedures from other service programs. Unlike the error handler routines that I showed you on, where are we today? Tuesday, which didn't need any other service programs. These particular modules use procedures from other service programs. As a result, you need to bind other service programs into this service program. So, in order to resolve the export symbol table, the import symbol table, of this service program, because that's the interesting part. A service program also has an import symbol table because it uses other service programs. I know I'm repeating myself, but I'm just making it quite clear. Now, when you are building service programs that require other service programs, your compiler, your CLLE compiler, must specify each additional service program required by name. And there's a very good reason for this, and we'll come to that later. But it is important that when you are compiling service programs, the other service programs you need are specified in this keyword by name. In order to tell the compiler for this service program, this create service program command has its export symbol table. You can see it there. But it also needs to be told where to go and look to resolve its import symbol table. Now, I will take the first module and just switch to the first module quickly. And you can see straight away, well, you should be able to see straight away. There's an error handler, because you will always find an error handler. So this particular module of this service program uses an error handler. So when I compile this service program, I have to specify that it must search the error handler service program to resolve that import symbol. I'll put this in the middle here so we can see all three at once. This procedure is required in this module, and therefore when I compile the service program which has that module in it, I need to include the service program that contains that procedure. Now you will notice that this particular set of modules which generates a service program uses actually a lot of other service programs. And it's quite possible that these service programs use other service programs. So there's quite a web of service programs that get tied together and references get resolved at compilation time as pointers. And this is why I stressed it on Tuesday, and I'm stressing it again now. It is important to follow these rules if you don't want to end up with a completely mangled mess, which is very, very difficult to untangle. So a rule about service programs is if they need other service programs, they must be specified explicitly when the service program is compiled. Okay, that is the circumstance. This is a service program that specifies which other service programs you need. And the reason why we do it this way, another reason why we do it this way, is once a service program is properly established and properly tested, it's pretty stable. That's why you can have many, many different service programs containing many different procedures. Those procedures can be subtly different. They can provide different services. But they are, once they are set up and tested, they're stable. It's not a good idea to change a procedure in a service program unless it's unavoidable. If you want a different function, create yourself a new procedure that provides an additional function. That's much easier and much cleaner. I tend to stay away from large amounts of conditioning for the function of a procedure. Okay, let's just go back here. So where I'm creating my service program, which is this left-hand side section, I should have put an import symbol table on the other side of the service program, only the screen doesn't provide me with space. So my create service program command specifies where to look if the service program requires to resolve import symbols. But what about a program? How do you tell a program where to look? Going the wrong way. How do you tell a program where to look to resolve its import symbols? And this is done by the use of a thing called a binding directory. Now I've just got to pick up an example of a bit of code that I have pretty much standard. I have standard HSpecs. I don't play a lot with conditional HSpecs or control specs or all that sort of thing. I just find those are too complicated. It's much better to actually break your procedures up into smaller pieces and avoid the necessity to do conditional compilation processes. It's bad enough having programs that do a lot of conditioning, but when you have to condition the compilation as well, it gets even more complicated. I usually end up, there is a main procedure name. This particular piece of code has no main line. It has a procedure that is called BLDOOF, and it's indicated as being the main procedure of this program by using the main keyword. So as a result, this program is compiled without those 25,000 lines of RPG cycle. That's the first thing. The second thing is we have a default activation group of no, because if you have a default, you cannot run procedures. You can't use the procedure functions of RPG4 in the default activation group. You have to be in an ILE activation group. Now, there's a whole topic about ILE activation groups later on in this course, but suffice it to say that you need your default activation group of no, and that is what allows you to use procedures in RPG4. We will discuss that and the activation group in great detail when we talk about activation groups. Here is the user profile. I tend to have a user profile style owner on all my programs. And the owner, of course, is the database owner, as well as the program owner. And that owner has all object authority. So programs using files do not have any authorization problems. But the important thing, if you use any modules or any procedures out of service programs, you need to tell the compiler where to look in order to resolve the import symbol table after the main program has been compiled. It needs to go and find the pointers for the import symbol table. And that is done by specifying during compilation a couple of things. You can either specify a binding directory, which contains a list of things. We'll call them things for the moment. Or, and I'm going to now drag this fellow in here, or create PGM F4, F10, yeah. You can list service programs, and that is what we do when we are creating service programs. If we need other service programs, we list them specifically. Or you can specify a list of binding directories, or both. A binding directory, work with binding directories. I wonder whether I'll find what I'm looking for here. There's a binding directory, but I don't like that one. I'm going to find a better one. I'm going to go to AO GPLD. There's a binding directory that is used by F0. Now, when I said the create program will allow you to specify either specific service programs to try and resolve the import symbols and or binding directories. That is what the command will allow you. The same command, create bound RPG, F10, default activation group, no, which I mentioned before, only allows you a list of binding directories. So the two commands provide you with different functionality. So after fighting with this and going through I suppose you could call it my blue phase when I was struggling with service programs and trying to find out what was the best way to deal with them, I came to realize that create bound RPG allows you binding directories only. Create program allows you binding directories as well as allowing you to specify individual service programs. And I decided to simplify the matter. And here's the name of the game. Binding directories are used only during compilation of programs and service programs. And they have a specific purpose, and I will show you what they consist of. This binding directory contains a list of all service programs that could contain procedures which are designed to satisfy an import symbol table. And I came to a conclusion after trying a number of different variations that the answer to the problem is very simple. You have a single binding directory. Note what I'm saying. A single binding directory, a single application-wide binding directory containing the name of every single service program that you have created for use by your applications. Because remember, the binding directory is only used during the final stages of compilation, which are the bind. And all the directory does is to give the compiler a list of service programs. And remember, each service program has an export symbol table. So all the compiler does when it wants to bind is it skims through each service program listed in the binding directory looks at its export symbol table to see whether it can satisfy an import symbol that is required by the program. So the conclusion I came to was eliminate all complication, all sources of confusion, and create a single application and enterprise-wide binding directory. And as you can see, I have called it services. I've also got one in the development environment. That under bar D is my development environment. I also have exactly the same in my test environment, and I have exactly the same in my production environment. When I create a new service program, it goes into the development level, where it can be tested and checked and made sure. And then as we go through the testing environment and into the production environment, I add that entry into the services binding directory at the test level and the production level. That means all your references to all your export symbols are all in one place. So the compiler only has to look in one place, which means that I can put it in the HSpec of every single program, and that program will always look and potentially find its import symbols somewhere in that binding directory. Now, let me just explain a binding directory entry. Once the compiler has compiled the program, and of course has got rid of all coding and syntax errors, it creates a list of import symbols. And the import symbols are identified by the PR, or the prototype statement, and the import symbols are then stacked, ready for binding. And the last phase of the compile procedure is to go looking for pointers to match those references. It will look in the services binding directory, and of course anywhere else you want it to look. You can specify 27 different binding directories for it to look in. But that's not a great idea because it gets confusing. And I'm all for simplifying the process. As much as possible. I don't like clutter, and I don't like to actually scratch around to look for things. I want to know exactly where they are. Ed. Okay, Ed's question. Okay, there's two questions there about this. If you have a service program with 20 procedures and your application program only uses 4 of them, then only those 4 will be imported. Actually, none will be imported. The pointers to the 4 that import symbol table uses. Remember, your program has got this service program may have many procedures, but your program only needs 4. As a result, only 4 locations will be embedded into the import symbol table. The actual code is not included, only the connection. This is why you can actually change the code of a service program, recompile the service program without having to recompile your application program. As long as you don't mess with these pointers in the export symbol table, as I explained on Tuesday. As long as you don't do that, it just simply finds the location of the 4. Bound by reference, in a sense, yes. The location is a pointer to the export symbol table, which has a physical address for the procedure. So in a way, it is bound by reference, and that is why you can change them and your program carries on using them. Just a word of warning here. If the program is actually open and is using a service program procedure, at the time that procedure is changed and recompiled, the program continues to use the old version of the procedure, which is cached, until the program closes down. Once the program closes down and reopens again, it will use the new version of the procedure. So if you have a never-ending program, you still have to close it down in order for it to get it to pick up the new version of the procedure. Yeah, if you don't do that, you do learn the hard way. Okay, if you change a module, do you use the... Okay, with that one, you can use either. You can use either. You can use the create service program, or you can use the update service program. But because of the fact that I actually create my compiler using a create service program, and I have all the modules and all the service programs and everything bound in there, I do a create service program every time. The update service program, I've never used it actually. I'm not 100% sure of what the difference actually is. It might be that it will update the program while somebody is still using it. If that's the case, well, you might like to create it the first time and then change this compiler program to do an update service program. But I have never used it. It's just unnecessarily complicated for me. And I've never had a problem recreating a service program, except if you have got a program that's actually using it. We do have a thread where this topic was actually discussed at some length. And I'll just on the AO forum. There was a question by a guy called Prashab who's been through this course. Why is it taking so long? Hello. Yeah, it's... Yeah, he had it's called activation group in never-ending batch. He has, for one of his customers, because he's a consultant, he actually had a never-ending background program that was running continuously. And as a result, every time they changed service programs, they had to close it down, which meant closing the applications down, and was quite a bit of nuisance. So we had a long discussion and a lot of investigation here, which you can read through to see the impact of that particular type of behavior, if you would like to look at it. However, where was I? Here's this program. So, no, we don't want to be. Here's the service. Here is my single one and only binding directory for my entire AO product. You can use it for your entire application, and I would recommend you do so. And again, we bump into a couple of rules. When you add service programs, they always, by definition, get added to the bottom. Now, you can see I've got a lot here. I've got quite a few service programs that service, because I actually practice what I preach in terms of the development. So I've got a lot of my code sitting in service programs where they do specific tasks. So you name the service program. That's the name of the service program. Then on this column, you've got two options. You can either specify the word module, or you can specify the word service program. Now, just be careful, and this is very important to understand. My binding directory called services only has service program entries. Remember, a service program is made up of modules, and each module has multiple procedures. If you include modules and service programs in the same binding directory, there's a very, very good chance that you could find duplicate names. And the compiler doesn't like that. The binding procedure does not like that. And it'll come up with an error and says, I have found duplicate procedure names. What do you want me to do about it? And the worst thing you can possibly do about it I'm just going to use the create program command because that one has the very obvious the creation options. One of the creation options is no dup prods. That's the default. Duproc. No duplicate procedures. That's the default. You can change it and say allow duprod, duplicate procedures. Let's just see what that actually does if I press F1. If you during the symbol resolution phase of the binding process, the procedure names that are exported from the modules and service programs do not have to be unique. Now, what happens if you have a duplicate procedure name during the final phase, the symbol resolution phase of the binding process? The binder will simply take the pointer to the first procedure that it finds while scanning your binding directory. It'll say, I got duplicates. I'll take the first one, and I will use that. Now, I got bitten, and more than once, by this, and it actually, because I wasn't being very careful about how I named my procedures. Next topic. Because I wasn't careful how I named my procedures, I was getting duplicate names. I.e., a procedure in one module had the same name as a procedure in another module, except they weren't the same procedure. So depending on the circumstances, when I compiled my program, under one compilation I got procedure number 1. And on another compilation I got procedure number 2. And I will tell you, there is no worse thing than chasing your tail, trying to find out why your program is ending up in a completely wrong place. You don't need that. So the important thing here is to keep things simple. There are other complications that occur if you mix modules and service programs in the same binding directory. But that's the worst one, that you can end up with a problem where you cannot compile a service program because there are modules that it's looking at that have the same procedure as the service program you're trying to compile. That's also another problem. So it gets very messy very quickly if you do not follow some basic rules. However, if you follow the basic rules, then it's actually not that bad. It's quite simple. So my services binding directory has service programs in it. If I wanted to, I could create a modules binding directory with only modules in it. But very careful that you don't have both of them specified in your program at the same time. Otherwise, you will end up getting duplicates, and you've got that issue. So this here is the library in which the service program can be found. I think all of us will agree that it's not smart to code anything else other than star library list. It's just not smart. Now, the next column is quite interesting. It's the activation column. It determines how this particular service program is going to be activated at the time the program needs it. Now, the star defer option says, defer the activation of this service program until I need one of the procedures in it. I.e., don't activate the service program unless I call the procedure, a procedure. Obviously, this is a performance issue, because in some applications, you may process 100,000 records and never call a particular procedure, in which case you don't want the service program to be activated, because if you activate the service program, it uses up more PAG, requires more memory. So the whole idea is, by default, to defer activation. However, and it will become clear, there are circumstances when you need immediate activation. And that is the subject of the next topic, which I will introduce now. There are some times when, in order to utilize functions within a service program, you need the service program to be activated at the time the program activates and not deferred, because the program wants that stuff in place before it can execute. So there are occasions when immediate activation is required. This is simply the creation date and time of the service program. And in some cases, if you have got something wrong in your binding directory and it can't find the service program because you've deleted it or it's in another somewhere else, this date and time will actually be blank to indicate that the service program is unavailable. So that is the binding directory. One binding directory, only with service programs in it, and you can, it's easy, it's simple. If you want to look for a service program, it's here. As long as you have that binding directory in your compile statement, your program will compile. And if your program doesn't compile and complains that it can't resolve to a particular procedure, then the answer is simple. You don't have to rush around. What it is, 99% of the time, if you follow these rules, is that you have created a new service program. And by the way, even though I've been doing this for, I don't know, close on 20 years, it catches me every single time. I create a new service program. It has a whole lot of procedures. I write code that uses those procedures. I try and compile that code. It fails because it can't resolve to the procedures, and I realize that I haven't added the service program to the binding directory. So I go into the binding directory, add the service program to the bottom of the binding directory, compile my program, and all is fine. However, if you've got these procedures scattered all over service programs and modules and you have to deal with duplicates, I never have a duplicate problem. You have to deal with duplicates or missing procedures. It's a little bit tricky. It just makes life complicated. So from a simplicity point of view, this is a binding directory. Now, I want to go back here to discuss names. One of the things I found in the early days of starting to build service programs, I gave the procedures within the service programs, and you can see from here, each of these modules has two procedures. I gave these procedures what I considered to be meaningful names, i.e. names that meant something and described the procedure, like my error handlers. My error handlers are called ERH03, ERH05, ERH10, and I thought this was wonderful. And as I am a lazy programmer, I kept them as short as possible, and I thought all was well with my life. Until I began to build up my library of service programs and procedures, and I started to find I had a problem. The first time I noticed I had a problem, you see there's a procedure, it's called check file. It's great. It says what it means. Level change. There's another one. Level change. But check file is a particular of interest. So the check file is the name of the procedure. And that was fine for a while. But then I find it became harder and harder and harder to get decent names without conflicting with ones I already had. But then there was another problem. If I looked at this check file name, is called check file, C-H-K-F-I-L-E. Now, that's a problem, because even if I look at the outline of this, RDI outline, very useful, we've talked about this before. Even if I look at the RDI outline and I open up the prototypes, I can find check file. It's in, here it is there, check file. You can see it's used in one place, there. It has, I didn't specify the external procedure name, but it actually compiles it in with the same name, check file, capitalizes it, puts quotes around it, and actually provides the external name. So what I'm facing with here is I've got a procedure buried somewhere in a service program called check file, in some module in a service program called check file. I can look at the sub-procedures for this particular program, and I can't find a thing called check file. It's not inside this particular program. It is somewhere else. It's a procedure that is in a module in a service program, and I have no indication whatsoever as to what and where it is. And this, and the naming conflicts, and the fact that I didn't really want to call it check file in one program because it was actually described in a different way, and I had to put notes in and all sorts. This created utter confusion for me. And I began to realize that I needed some sort of standardized methodology for defining procedures inside modules, inside service programs. So here it is. I'm giving it to you as the method that really did work for me. And you're more than welcome to use it. It's worked for me, it's clear, and it works, and I will show you why. Let's have a look at this module. This is a newer module, and you will see that it is DBWB SRV. It has an at in it, and the module is the 0 module. It's the first module. I can explain what this module contains or what it's dealing with in the text. So here we have a name. It's DBWB SRV at, saying it's a module, 00, it's module 0. Then within this module, each procedure has a letter. At the end of the module name. So the procedure name within the module is module name plus a letter A to Z. So I can get 26 different procedures in one module. I don't go beyond that because it gets too big. What I do is I also put in a comment line, a description of what the procedure is, and I have the prototype, which of course is the A, module name with an A. But I also stick in a comment line, and this is a more meaningful name. It also has the external procedure name, and I can copy this into a program and take away the star. So I create a comment line, for example, that gives this thing a meaningful name, which is something along the lines of a description. Turn the lock on, turn the lock off, get a pointer to the LDA, so on and so forth. Now, this is the way I create my procedures. In the module inside the service program, that's how they're named. A, B, this one has a parameter, a return value. So this one here, because it returns a value, it returns an indicator, this one is actually not a procedure, it's a function. Whereas the one before doesn't return anything, it's a procedure, not a function. Semantics, but it's a good idea to be aware of that. So when somebody refers to a function, like this one is a function because it returns a system pointer, so on and so forth. They all have the same naming convention. They match the module, and of course, they match, you get all the modules for your service program, and you compile, you bind them all together and create a service program called that, which is DBWB-SRV at. There's a double at the end, which indicates that it's a service program. Makes it easy to find, easy to identify. When you want to use one of these procedures in a program, you give it a name that has meaning and documentational benefit for the program. And you then use the external procedure keyword to name the actual procedure that is used in the service program. This way, you can make it sensible and you can say, this is a level change. It's returning an indicator, so this procedure returns me a level change indicator. And I use this procedure in that service program. In this case, I've got 3 noughts. In that module, and the service program that I'll find it in is that with another @ sign at the end. So by looking at my code, I can immediately identify whether it's local, because let me just see where I was with this. A local sub-procedure is this one here, allocate logicals. You will see it's a local to this particular program, and it has a prototype which doesn't have an external procedure. So the convention that's evolved over time for me is that any procedures that are internal to the program I'm actually looking at do not have an external proc keyword. All those that are external, i.e. they're in service programs some way, they have an external proc keyword, and the naming tells me the service program, the module, and the procedure within that external service program. Now, I would like to save you some pain, because service programs, and this is one of the major reasons why people abandon the use of service programs, because they hurt. They're very painful. They confuse utterly, to the extent that you can't find the module, you can't find the procedure, and the risk there is that you begin to duplicate modules and procedures, which of course is exactly what we don't want to do when you're modernizing your application. You want to create a procedure that does one thing. It does A. You write the code to do A, and you only write it once. You never write it again. Therefore, it has to be well documented and well sorted out. So this naming convention works for me. Obviously, you can make up your own naming convention, but you do need to have some relationship between the program, what it's called in the program, what service program it's in, what module it's in, and what procedure it is, so you can find it easily. The other huge advantage of this is, despite whatever it happens to be called in this program, I can find, by doing this and taking just that piece of it, that's a module name. I know it's a module name. I can use the search function of RDI to search for any other programs that are using that module very quickly. Except my line is being a bit slow this afternoon. But it can search for anything using that module regardless, regardless of what it's called inside the program. So there's this one is only being used at the moment by BLD00F. But that's in the development environment. It may be used elsewhere. But using the search function allows you to walk around, and that's why I stress you need some standardized naming convention for your service programs. And by using this double naming, You can call it what you like and what suits inside the program, but outside the program it has a consistent name. And you will see here, these names are all exactly the same right throughout. This is the binder source, which controls the export symbol table. Okay. Any questions on that topic? We've had a couple. Any more? Because I want to go on and I want to discuss another type of service program export, which is very, very powerful. So if you could just give me a moment, I'll be back in 2 seconds. I just need to get myself a glass of water. Thanks. Sorry about that. Okay, back to the drawing board. In the same way, this I've got here up on the screen on the left-hand side, is a module containing procedures. The procedure is identified by a P type or by the DCL-PR if you're in fully freeform. It's the beginning of that procedure, and it has an export keyword. The export keyword says it can be exported from the service program, i.e. it can be made available in an export symbol table. But if you are controlling your service program using binder source and you do not include this one in the binder source table, it will not be exported. So you can have the export keyword, but actually exclude it from the export symbol table. There is one condition, and I'm not even going to go into it, where that is actually practical or actually is necessary. But it's not, it's very esoteric. And as a result, I don't want to confuse the issue at this point in time. So that export keyword exports the procedure to the export symbol table. And it means then that that procedure name is available for binding into programs. That's the thing. Now, we come to another type of structure. You can find my, here's one. Here's a good one. These are other things that you can use the export keyword on. Now remember, we are still in a module inside a service program, and the module contains procedures. But in this case, this module also contains export data items. You can export a data structure. You can export a standalone field. You can actually export any type of data definition that you want. These are system pointers. I export system pointers. If you specify these in your export symbol table, they get added to the service program's export symbol table. Then in your program, let me see if I can find one. You have another keyword, import, which means that this program wants to import that named system pointer into this program. Now, if you look carefully, it's an export from the binding directory for that particular service program. So, what you have is you have a pointer, there it is there, that is defined within the service program, and it is indicated as being exportable. Remember, a pointer is 16 bytes. It's indicated as being exportable. And therefore, the service program is the place where that particular pointer, or we can choose this one, where this particular data structure is defined, i.e., the actual physical content of that data structure that I've highlighted there exists inside the service program, exists within the service program. I don't have this one importing from let me see. Just looking for the opposite for that data, that particular data structure. Yeah, there it is there. There's the data structure. Actually, this is a module that exists in another service program. It's actually importing that particular data structure. So what it is that this module that you're seeing here, or let me put that one over to this side, this module is sharing the same space with this module, because this is exporting a data structure and this module is importing a data structure. Now, this can get extremely complicated, and you're going to need to play with this often. But what we are used to in the past is when we call procedures, specifically, we design the procedures to receive parameters, i.e. the parameters are passed by reference, they are pointers. And you've got a procedure, it's got an input parameter string, and you've got, using the procedure, you have to create an output parameter stream, a parameter list. However, if you are using exported and imported data elements or data structures between programs, this program I think does have import. You can see it has imports of different pointers. These are shared between the service program where they're defined and any program or other module that uses them as an import. And using this technique, you can avoid passing parameters on a call. You can make the information that you want common. You can make it common by actually defining it inside a service program that is being used by multiple different procedures and programs. I'm not going to go into this one in too much detail because any more detail, except to say that if this source information was exported, it was exported with that name. If I wanted to import it with a different name, for example, if I wanted to change this name to source, all I would need to do is to actually name this like that. Please understand, I'm sure you're all aware that the upper lowercase in RPG is readability stuff. But when you're specifying names after compilation, everything is in uppercase. So you need, if you're quoting it, you need to specify it in full. But by doing that, you are actually importing exactly the same data structures as being exported here, only with a different name. Okay. Here's one of the nicest things about RDI is that it has an undo function. Not just one F5 if you have not yet pressed the enter key. You can undo as many times as you like until you can't undo anymore. The depth of the undo, I think, is 9,999 or something. But not only that, you can redo if you go too far. So that is a major benefit for me, because I tend to get excited, type code, and then realize I've messed it up, and I can actually just undo it. Right, so here we're talking about having data items exported from one service program and imported into other service programs and other programs. And what you have to get a mental picture of here is that, in fact, it is the same space. It exists where it is defined as export, and a data element can only be defined as export in one particular module. If you attempt to compile a program or service program which uses the export keyword on two data items that have the same name, you will get a compilation failure. It just doesn't compile. So you export from one place. It is nice to export from the service program, because then when you export from the service program, any program or other module, procedure, or service program can actually import it and use it. And it becomes common data across the board. Please note that export data items have to be defined in the global data area for a module. They cannot be defined within the local data area inside a procedure. They have to be defined within the global data area of the module, which occurs before the first procedure is actually defined, before the first P-spec. That is the global data definition area. So exports have to be defined in that area. Now, data exports and imports are one of the reasons why you would need to change the activation to immediate. If you want that particular data element to be available at start of program, then you must define that service program containing those elements as immediate activation. If you don't, then you will find that all too common thing, pointer not set for location referenced, because the import export pointers will not have been established. They will have been compiled to point in the right place, but they won't actually have been established in your program until you call the service program. So if you want the program to provide a value to the service program, you have to use an immediate activation. If, of course, you call the service program, any procedure in the service program, before you require to populate that data element, then those data, the export data elements are initialized and activated, and then they become available. So that is the one reason why this particular service program here has some export fields that are not populated by this service program, they're populated by external programs. And therefore, this has to be an immediate activation. Otherwise, I can't do that. This is great fun. It cuts down the need for lines and lines and lines of code, making it very simple. Here is a statement where I set the value of that pointer to be 400 bytes away from that pointer. And of course, LDAP is an export, and 110FP is also an export. So this particular module is actually initializing certain values. But you can use them from either direction. And they reduce extraordinarily the amount of unnecessary code. You can move entire record structures from a program to a service program and then out to another program or to another call procedure without having to pass a single parameter, without having to do anything at all, because it's sharing common data space. Very worthwhile practicing with it. Take it slowly, please, because you are going to get confused. And I'm not saying that with any unpleasantness at all. This is guaranteed at the beginning to get confused. What I've tried to do here is to give you the rules that have worked for me for years. And you can actually bypass the pain of not being able to find a procedure and having to virtually dismantle your entire service program library in order to find something, in order to work with it or understand it or change it or do whatever you need to do with it. Of course, the other trick which can help is you can use the RDI interactive debug, which means that if you have a call to a prototype or procedure like that one, for example, which is a procedure, your debug will take you into it if you press the equivalent of F22. Or in the case of the debug perspective, that's the step into, that's the step over, and that's the step to return. So if you use a step into, it actually steps you into the service program. And you can then track down where it is and where it belongs. That's the only other option you have. But using good naming conventions is a much easier way, and it's a good, tidy practice to start with from the very beginning. So I'm more than happy to cover it again if you have questions or you want me to have a look at any standards that you guys might have so that I can give you an opinion. I'm more than happy to do so. Okay, that brings to an end service programs. I'm going to just take a sip of water and see if there are any questions. Are you all making notes or are you relying on the recordings? Yeah, okay. All right, so no questions on service programs. These are the places where you store, they're a library. They're a library of common routines. And let me tell you something. I have a lot of service program procedures that at the present moment are only used once. But the very nature of that procedure says it would be very useful for me to separate it and keep it in a service program as a separate procedure, because I know I'm going to need that again. Maybe not now, maybe not immediately, but sometime in the future I'm going to need it. And I tend to do that quite a lot, maybe a little bit too much. But I prefer to do it that way and not have the pain of actually duplicating code inside my application code, or not having to extract it later from 7 different programs and combine it into a single service procedure. So service programs are, to my mind, libraries where you can put common code procedures and the code that you think may be used more than once in the future. Because they are bound to a program at compile time, the performance is faster than the old program call or even the external call proc. You know, the normal external call procedure, they're faster. You can change them as long as you follow the golden rules I've already given you. Keep the signature the same, don't change the parameters, and keep your export symbol table the same. Those, you can change them. You don't have to recompile your programs. You can enhance them. And in fact, a bit later on, we will talk about using service programs stacked with procedures to use as validation procedures for trigger programs. That's a game I'm developing at the moment, where all the validation rules are stored inside service programs and are called by procedures. The operation is very fast, very efficient, and easy to use if you can keep it down to a basic structure. Don't get smart with this, because if you get smart with it, you're going to get pain, I promise. I've been there. And I can send you each one a tatty t-shirt with the pain of how I've sorted this out. So please, don't get smart. Rather start simple and clean. You can get clever later on. Right. No questions I see, and I'm not going to babble on too much, so we're going to begin on the next topic. If I can remember what it is. Okay, here's some do's and don'ts. Why did I? Oh, okay. Always use the binder source. Sorry, I'm going. There's my starting picture from the beginning, and there's my. Right. Now, physical tables, normalized physical tables, referential and other constraints, primary key constraints, unique constraints, and check constraints, together with triggers, make up IBM I's official DB2 relational database construct. Of course, that includes journals and commitment control as well. Those all are part of the IBM I operating system's official version of DB2, relational database. But over the years, I have realized that when you're modernizing an application, you need to separate the actual I/O functionality. Take it out of the program and put it in between the application programs and the database. So I created a thing called an I/O server. I called them I/O servers. and they are input-output services. And the way they work is this. They have numerous benefits, numerous benefits. And so let me explain how they work. We have an application program A that wishes to write, update, or delete a record from table A. So what it would normally do is it would issue the request to the relational database management system, and all triggers and constraints being satisfied, which is always a proviso on this lot, that request will be executed onto table A. And the triggers, RDBMS, and everything else would return back to application program A an acknowledgement that their request was successful. In fact, it doesn't get an acknowledgement that the request was successful. It just gets sent back absolute silence. They get shouted at when it doesn't work. That's the way of the thing. Then application program A, oh, by the way, that particular request has created, where this arrow sits here, has created a thing called an open data path. It's opened a data path to table A. It has created a file definition table in the PAG. So when program A calls program B, and program B also wants to do some sort of interaction with table A, that creates a second open data path. Unless you go to the trouble of doing a database override. Again, while I was developing the IO server concept, I began to realize that these overrides were complicated, they were difficult, and they created issues because in some cases they happened and they worked properly, in the other cases they didn't. So this was part of the thing process. So here I've got open data paths. What happens, of course, when you have two open data paths, in your PAG, process access group, which is an object that is assigned to every job that is opened on the IBMI and requires to be in memory for the job to do anything, will, because there are two open data paths, will get two file definition tables, two file buffers, and two file record pointers, which doubles the PAG, or doubles the space used for that particular one table, which you want to avoid. The other thing is this application program B has to go through the open data path, the file open the second time. This one opens the file, this one opens the file the second time. So not only do you have excessive PAG usage, but you also have the overhead of having to do an actual file open twice, all for the same program. Now, modernizing your application code, you often get this situation where program A will, for example, read a record out of the file, pass control to program B, which will update that record. Now, that means application A will do a read to get the record, pass control to application program B. Application program B will require to do an update, so it will have to do a read before it can do an update. And it gets very complicated. So the concept of the IO server is as follows, and this is basically the change. We create a RPG object. This here, this IO server is an RPG module. It can also, if you absolutely insist, it could be a SQL module, it could be a C module, it could be any other module written in any particular programming language you like, because we are in an ILE environment. However, I use RPG and only RPG. The I/O server is then the conduit to the table. So application program A will pass the request for whatever it wants to the I/O server, who will then check to see whether the file is open. If not, it'll open the file, it'll pass the request through RDBMS to the table. It will receive the response, of course, based on, let's go to the big picture. Any before and after triggers will take action at this particular point through RDBMS, and the control will be returned to the I/O server that initiated the call. There are multiple. What I tend to do is I tend to have one I/O server per table, a one-for-one relationship, because otherwise you have too much conditioning and too many issues. Sorry, I'm hearing things bleep and so on and so forth, so I just want... Okay. So, let's have a look at this. I/O servers act as a sort of border patrol. What you are doing here is you are separating the actual job of input-output from the application. So the application no longer directly does input-output to the table. It does it through the I/O server. Now, this can create a number of benefits, and let me itemize them. The first benefit is that the I/O server can then be used to contain information or contain processes that are applicable to the input or output to or from a table. Now, that's an important consideration, because that is code that is written into the I/O server. It's written into the I/O server, and it behaves in a similar way to the other service program procedures we were talking about. You write a particular behavior for a particular file or particular table. You write certain behaviors relating to I/O on that table into the I/O server, and that means they do not have to be written into the application program. So once again, you are devolving, shall we say, certain actions that need to be written there and there. You're devolving them to a single place, the I/O server. I will show you clear examples of how this sort of thing works. I'm just trying to give you an overview of the picture. So, common code that relates to the input-output services for a particular table can be written into an I/O server. A simple example would be a customer number. If the insert function requires that a new customer gets the next number in the list, which is pretty common, that process can be done inside the I/O server to actually go and fetch the next number that's to be used, add it to the record before the record is written to the table. Now, all of you are probably, I hope, thinking, oh, that's interesting. Why don't we do that in the before trigger? Because you can actually change records in the before trigger, so why not add a new number into the before trigger? No? Okay. The reason for that is that the record, the actual record that is being inserted by this program, is passed to the I/O server, that record is shared. It's an import-export situation. So that record is shared by the I/O server and the program. When the I/O server adds the customer number into that record, inserts the record into the table and returns control to the application program, the customer number is available to the application program because they are sharing the record structure. If you do that function in the before trigger, which you can do, you can in the before trigger add one to a data area which contains the last customer number used, and you can put it into the record and it will write it to the file. But that record is not then available to the application program. So in order to retrieve the record that program A has just written into the table, program B would have to chain to the table to get the record. But program B couldn't chain to the table to get the record because program B doesn't know what a customer number is. Whereas the I/O server has a common area, has a common record between program A, the I/O server, and program B. So the information is available to all three of those objects, which is why we do that type of behavior in the I/O server rather than in the trigger. There's another thing that is, to my mind, probably the most important thing about an I/O server and its functionality. I'm going to ask for a quick demute for all those people who have their entire database protected by a public exclude authority. If you have, please switch off your mute. I'm talking about every database file in your database is protected by a public authority of *exclude. Okay, I got no takers, which is not a surprise. If you have a public authority on any table in your database other than *exclude, you are at risk because SQL clients have access to your table. You then have to go to the extremes of authorizing or deauthorizing individual user profiles or groups of profiles to the table or tables that make up your database. Now, in the case where I/O servers are handling the I/O to the database, the I/O server is a program. It adopts owner authority. The owner of the I/O server is the same person who owns the table. And the table says public exclude. So the only person who can touch that table is the owner. But the owner is not a logon profile. And the only programs that have that profile are the I/O servers, and they adopt the owner profiles. So basically, the tables have public exclude, and the only program that can access those tables is the I/O server. Which means that if anybody tries to access your database through an alternative SQL client, they will get rejected as not being authorized. The only thing that can access the table is the I/O server. But the I/O server has to be properly called from within an application program. The I/O server has a public *use, and it has to have an application program calling it and passing it the correct parameters. So it is almost impossible for a SQL client to utilize an IO server, because IO servers are written in RPG and SQL clients don't directly access IO servers programs. So what you're doing is you're creating an incredibly high level of data security by shutting down access to your database and allowing official applications unrestricted access through the IO server. And this is honestly probably the most serious consideration for IO server development, is that there's no other way to protect your data from unauthorized access without a large and hugely complicated access definition system. Just to give you an example, I worked for somebody in South Africa numerous years ago. I was teaching Query 400 to their users. And I said to them, look, I need access to a database so I can demonstrate how you build queries and how you read them, and I need access to this database. And they said, all right, they think that the best database is the personnel database, and they would give me access to it. I said, that's super. Can I come in tomorrow and do the training? I mean, you know, when can I do the training? They said, no, unfortunately, it's going to take us a while to give you access to our database. So you have to give us 2 weeks. I said, 2 weeks? They explained to me that, yes, first of all, they have to put in a request, and it has to go and get authorized and signed off, etc., etc. But then their access control person had to sit down and had to put my name and my authority on every single one of their physical database tables in that database, individually, one at a time, in order to give me access. And that would take him at least 3 to 4 days. And I thought that is the wrong way to protect your data. And all of these things led to this IO server, where you go through your entire database and you make all the tables public exclude. Obviously, you won't do this, otherwise your existing application will crash, and you will have a great deal of pain. But you create an IO server, you find out who is using that table, you convert those programs to use the IO server, and then that table can be switched to public exclude. So you never do these things in a big bang format, because that's crazy. But you can do it one file at a time, one program at a time, it doesn't matter. The important thing, and I think right at the top of this whole process, I gave you a quote from Alvin Toffler that says one has to have a picture of the direction in which you're going, so that when you get to do all the little things, like IO servers, they all go in the same direction. You don't want everything to go in all sorts of directions. And this is the whole point. You adopt a philosophy, it doesn't have to and can't be done this week. It's just not possible. But you can always work towards the philosophy which says, if I have to change something, I must fix it in line with the long-term strategy for modernization. And one will actually be surprised how quickly that happens. And then, of course, as things get better and better, your programmers are sitting around doing nothing because everything is working so well. You can get them to pick up another program or another file and do an IO server for that and triggers for that. And so the whole thing evolves faster and faster and faster. But the potential for an IO server to protect the data in your database from unauthorized access cannot be stressed enough. Also, of course, your PAG only has one open instance of the table A. And as long as you keep using that one IO server, application programs, service program procedures, everything that uses that one I/O server, all use the same open data path. So you reduce the size of your PAG. You don't ever have to worry about doing overrides, because if you use that I/O server, you are using the same open data path. Obviously in the job. If you open that I/O server in another job, that job has its own data path. So by using the I/O server, you're channeling everything through a single data path. It may sound like it could have a problem, but it doesn't. Because again, most of what we do here is interactive, and as I said before, the time between the user pressing the enter key and looking up to see what's happened on the screen is a century as far as the processor is concerned. And transaction processing in batch, as I said earlier, we should be trying to get rid of, but batch processing is sequential when it's processing a data table, so it keeps using the same open data path sequentially. So I/O servers don't even have the same problem as triggers. They don't add an overhead. They do things on the way through. Okay, this line here is then basically the barrier, the border between the application and the database. And the I/O servers act as the border control. They manage the access of the applications to the database under control of the I/O of the triggers, both before and after. And the I/O servers may react to a particular trigger issue on behalf of the application, i.e. the I/O server may not even let a particular problem get back to the application program. It may fix it there. We'll have a look at some examples. Any questions so far? Yes, we have got some. Don't you still have to control who can call the I/O server program? Yeah, we don't want developers updating production data. Well, developers should never be working in a production environment anyway. And remember that this I/O server is a program. And the I/O server must exist for a particular level of development, either development, test, or production, in the library with the library list. It's part of the database. And because the library list controls what table the I/O server is going to actually process, as long as you manage your library list correctly, you won't have that problem. Does that answer the question, Dean? If there are 10 programs using a file and I create an I/O server and change one of the programs to use the I/O server, can I place that into production? Yes, you can. In fact, you can create an I/O server, test it, put it into production without any program actually using it. It's going to cost you nothing. Then you can change your application programs as you see fit to channel their I/O through the I/O server, so that it's, again, this is where our roadmap is so important in its approach. Nothing has to be done in a big lump. It can all be done in tiny little pieces. So yes, you can create the I/O server, use it on one application, but not in others. The only thing that will happen is if you have 2 programs using an I/O server, they'll open one data path. If another program accesses the file directly, that will be another data path. So you will have 2 data paths. But remember, if these are in different jobs, they're going to be different data paths anyway, because each job has its own instance of the I/O server and its own instance of the open data path. Yes, it is. Service programs are faster than external program calls. My guess is probably by a factor of about 300. But if anybody asked me to prove that, I couldn't. Okay, Dean, let's see. You've got test and production on the same partition. But you should not have them in the same libraries, in the same schemas. In this particular case, it's all to do with how you construct your library list. But you're right. You can provide the necessary authority to the IO servers to exclude your developers. But then how are they going to test their development? So you would put a copy of the IO server into the development environments database. Because remember, the whole crux of this matter is that the database in development and the database in production are structurally identical. They may not contain the same data, but they are structurally identical in every respect, i.e. they have the same files, they have the same triggers, they have the same constraints, they have the same keys, etc., and of course the same IO servers. They're physically, structurally identical, only contained in different libraries. You can't have a development environment that only has a part of your database in it, because you can never test properly. Oh, okay. Dev, you've got, sorry, Dean. Dev, you've got on a different partition. Test and production on the same partition. Okay. There you can juggle. It's actually not so difficult. You can actually exclude the developers from your test and production environments. But you don't need to, because it's the applications themselves and people that are using them that are the important thing. The IO server is just another way of doing an S-spec, but more efficiently. Does that sort of answer, or do we need to go into that in a bit more depth? Okay, good. Look, we'll talk a little bit more, and there'll be another opportunity Tuesday to ask more questions, because we still got we've got to do a little bit of a dive into this IO services to make sure it's well understood. Because again, like the trigger, what this IO server does is really limited by your imagination and only your imagination. Okay, so we've got a few minutes. Let me proceed with the, right. This is the little diagram. I've jazzed it up a little bit, and I've got rid of one file that kept getting in the way. But we've got our customer master file, our rep master file, our customer balances file. We've got our header file, we've got our detail file, and we've got an invoice detail before trigger and after trigger, and we've got a before and after customer master trigger. This is basically what we are going to work around to understand how this whole thing fits together. Now what I want to do is I want to move that up a little bit. Why did I don't know why that went green. That shouldn't be. Oh, that's an access. Now, let's look at where the IO servers fit in. And IO servers are written as modules. Each IO server is written as a module. It has one exportable, although it can have more than one exportable procedure, depending on how you want to construct your IO server. But generally speaking, the IO server, one file, one IO server. You can if you want to have I/O servers that handle more than one file. But that is not really an input-output server. That becomes more an enterprise server where it's doing a lot more. So generally speaking, I start with a one-to-one relationship between an I/O server and its file. I take those servers, which are procedures in a module. So each module refers to a particular file, and I take all those modules and I bind them into a service program, which in this case I called working database I/O servers, with an at the end to indicate they are service programs. Now, I create these I/O servers, one for one, and they become such a natural part of building the database. If I build a new file on the database, I build triggers, and I build I/O servers for that new file. Quite simply, it's a habit. So let's just see what we get next. Right, let's look at what happens here. This invoice detail after trigger, that one there, is going to use the invoice header I/O server. Because remember, this after trigger is synchronizing the totals in the header file with the invoice detail record that's been changed, added, or deleted from the detail. So the header, the I/O server then does the I/O on behalf of that trigger. So here we have a trigger updating a file in the database through an I/O server. This has nothing whatsoever to do with your application. It's all internal to the database's production. So here's another one. We want to increase if there's an insert, or we want to change the customer's balance. So we would use this I/O server to change the balances file from that same trigger. This customer master after trigger, we also discussed this. It was designed to add a balance record to the balances file when you inserted a customer. So it uses exactly the same I/O server to update the balances file as the detail after trigger uses to update the balances file. So in this scenario, if you've got somebody who's working in this environment, you've got, these are your I/O servers, and they are all taking care of the I/O. Here you have app code, and they are also capable of using the I/O servers to make changes to the database, all under the control of this particular service program and these I/O servers, and the service program adopts owner authority. These I/O servers are modules, and therefore they don't have any adoption. It's the service program that adopts owner authority. Now I have to check that I'm not telling you a lie, because I definitely don't want to do that. Create SRV PGM F4 F10 there it is there. So the service program can adopt the owner authority. Create RPG mod does not have the ability to adopt owner authority. Therefore, if you take all these I/O services modules and bind them into a service program, all of them will adopt the owner authority. Makes life easy. They all adopt the same owner's authority. And the control of your database is then more secure. And you can add IO servers to this service program as time goes by. Each one that you add will adopt owner authority, and so the benefits will accrue as you go one small step at a time. Okay, we've talked about the theory of IO servers, and I think I've got to do this again. I mean, my timing at this particular moment was absolutely stunning. Occasionally I hit the nail on the head. Physical database, we're talking modern. DDS to DDL, yes, but you can get away without doing it, or you can do it only for some files. Depends where you want to gain the most benefit. The logical database we haven't discussed yet. There's your trigger programs, which are providing services to the database. Then we have our IO services, which, incidentally, this arrow might be of interest to you. When I create logical files in my database, I also create IO services modules for logical files. And it's, you know, I'm sure, that there are certain types of logical file that you cannot do an update on, like a DDS join, SQL view. These you cannot do updates on. But if you have an IO server, and I will show you an example of this, if you have an IO server, you can actually update logical files which technically are not updatable. Because all your IO server has to do is to update the 2 physical files or the 3 physical files that are associated with that logical file. And hey presto, the job is done. So your application just updates files and couldn't care less whether they're joined views or what, because they can do them through IO servers. And IO server is coded to take care of the complications. So we are at this level, apart from the logical database, which we haven't done. The next one we're going to look at is a combination of IO services and enterprise services, which is more on the application side of the line rather than on the database side of the line. So really, the IO services is where the database is separated from the applications. One day I'll learn to draw straight with a mouse, but until then, I apologize. So that really takes us to the end of this particular session. And if there are any quick questions, I'll take them. Otherwise, if you have questions, once you've reviewed the recording, you can send them to me via email. I just have to point out to you that I will be traveling to Wisconsin for the spring conference, where I'm delivering 4 sessions. I will be traveling. Okay, my email, Tommy A, T-O-M-M-Y-A, at Tembo, T-E-M-B-O, techlab, T-E-C-H-L-A-B.com. Let me see if I can pop up. Ah, thank you, Marinus. I didn't think of doing that. I must be tired. That's my email address. I will be, as I was saying, I will be traveling to Wisconsin. I'm leaving on the 11th of March. So the sessions, and I will be there for 2 weeks. So the sessions from the 14th, 16th, 21st, 23rd, and in fact, because I'm getting back pretty late, the 28th and 30th will also, those 6 sessions will be moved, and we will start again on the 4th of April. So it is the 4th of April, yes. Marina says he will send an email to everybody just to identify which sessions are going to be moved, and he will update the meeting schedule to inform you. So there will be a break. We've got, as we speak now, we've got 2 more sessions next week, where we will get to actually a very good point where we will be able to take a break. And you will be able to, because we will have finished the database side of things. And when I get back in April, we will then start on the application development side of things. So that is the situation as we stand at the moment. But as I say, send me mails if you have questions. I will include them in the next 2 sessions or session. And we will look at IO servers in a lot more detail. Thank you very much. Have a great day, and look forward to meeting you again next week. Bye.